normally wear my hat, but it doesn't really work with this microphone, so I feel kind of naked. Hello, so my name is Sean Griffin. I maintain a web framework called Ruby on Rails. I'm at SGRIF on Twitter. If you want to tweet at me while I'm giving this presentation, that's how I'm going to judge my self-esteem afterwards. So, if you want to, there it is. If not, that's okay. I'll just go cry in the bathroom. Anyway, so I'd like to start this talk with a very controversial statement. Ruby, JavaScript, and Python are dynamically typed languages. And I'm sorry if I made anybody do a spit take there. But the important point that I'd like to make about this is that just because these languages are dynamically typed, it doesn't give you, what I mean when I say it is dynamically typed, is that it does not give you a way to express types or verify that your code is well typed. But the thing is, your program is going to have types either way. It doesn't matter if you're working in a statically typed language or a dynamically typed one. You still have types. You still expect a variable to adhere to a certain interface. You still reason about your program based on the types of your objects. And by type, I don't mean the specific class of an object. Thing that responds to toString is still a type. And when you think about your program this way, well, of course your program has types. If something didn't have a type, then you wouldn't be able to do anything with it. In fact, I mentor at a program, or I used to mentor at a program in Denver called Turing, and when the students would start to get lost, they would be learning Ruby as their first programming language. One of the questions I would ask to get them back on track is, what are the types here? What do you expect? What do you need? How do you get from A to B? Types are a lovely thing. Thinking about them in the back of your mind when you're writing your code helps to prevent a lot of bugs. So the point to all of this is that semantics still exist, regardless of whether or not you're working in a language that gives you a way to express them or to enforce them. So types are one type of semantic that some languages don't have. Let's talk about another type of semantics that these languages, quote, don't have. So ownership is something that was explored a bit in C++ starting in 2011, but was truly introduced to the world by a new programming language called Rust. Rust was introduced last year by Mozilla. So all values have an owner. You either own an object or you're borrowing it. So what does it mean to own an object? In the simplest sense, owning something means that you have the right to destroy it. So now you might be asking, well, what does it mean to destroy something? It actually doesn't specifically matter what destruction means, other than that after something has been destroyed, you aren't allowed to use it anymore. So now you might be asking, what's an example of something that can no longer be used after it's been destroyed? You might also be asking when I'm going to stop answering these questions with more questions. Okay, so let's take a look at some code. I'm going to show some examples in Rust because it's the only language that has syntactic ways to express ownership, and that's what we're trying to demonstrate. We're going to work with the file type because that is something that has very clear destruction semantics in almost every language. You open up a file handle, and at some point you're going to call close on it. And you aren't, if you're in an object-oriented language, you likely have a single object there, and you should not be using a file handle after it's been closed, or bad things will happen. So we've got two functions here. The first one is going to do some stuff with a file, and the body is completely empty there, because what it's doing doesn't matter, but it takes in a file. And specifically because it takes a file, that in Rust is referred to as taking ownership of it. So when you call this function, the value is going to be moved in there. And so when the function returns, that file will be destroyed. And so in our main function here, we're opening up a file. We're going to try and do stuff with it. And if we try and do more stuff with the same file, we would get a compiler error because we have moved that in somewhere else. We no longer own that file, so we are no longer allowed to use it. Now, it wouldn't be terribly useful if you could only ever pass a value to a function exactly one time, so this is why we have borrowing. So this is the same example, but you'll notice that in that first function, we take an ampersand file instead of just a file. So that means that this function wants to borrow a file. and then we put ampersands in front of it when we're calling it. So the first time we're borrowing it, there are limits to what we can do with it when something is being borrowed, which are not super relevant to the general concept of ownership, but then we can pass ownership to it later on because we have not given up ownership. So a reference, for those of you who've worked in C-like languages, a reference in Rust is, there are mutable and immutable references or shared and unique references, depending on how you want to talk about it, but it's just a pointer that's guaranteed to be non-null. For those of you who haven't worked in C-like languages, or if what I just said made no sense, I'm very jealous of you, and I hope that you never have to work in C-like languages. One other thing that comes out of this, at least in Rust, is mutable versus immutable references. So you can pass around a mutable reference to something, but you can only ever have one mutable reference, and you can only mutate something if you are the only person or the only code that has access to that data. You cannot share and mutate at the same time. So objects or structs can own things. It's not just functions. This goes into the definition of a type. You say whether its fields, whether it owns those fields, or whether it borrows those things. If you store something in an instance variable in a language like Ruby or Python, you almost always own it. It's very rare to have actual sharing between that in most programs. One thing I've noticed as I've started to think about ownership while writing Ruby is that I've started to notice that God objects in my system also tend to own a lot of stuff. So, and God object is a term that we refer to for something that a lot of things need to know about or has a lot of behavior on it. But if we focus less on it has too much behavior and more on it owns too many things, then I would like to propose that we rename God object to, I don't know if you've heard, he claims he's very rich. Also, it's Canada Day. I was thinking about cutting this since I'm not in America, but since I think I'm going to have some new neighbors soon, potentially, I thought it'd be... So there's one other caveat, and there are certain types which just, like these semantics, completely do not apply at all. We call these types copy in Rust, and it's basically anything where you can copy this as many times, and it doesn't matter. These are things like Booleans and numbers, things where the immutable value types, basically. Nobody owns the number 3, although Trump might try to, I don't know. All right, so let's go back to the original point. So owning an object means that you have the right to destroy it. Values have exactly one owner. If you need to temporarily do something with an object, you borrow it, and things can be borrowed either mutably or immutably. So my original, the first slide I had here, right? Ruby, JavaScript, and Python are dynamically typed. But your code still has to reason about types. And these are languages that also don't have an explicit concept of ownership. But I would like to propose that your code still has to reason about ownership. Because semantics still exist, regardless of whether languages give you an explicit way to express them or to enforce them. So I'm showing a language that there's probably like 2 people in here who've ever seen before and nobody cares about. So let's look at some examples that are in other languages. So this is an example in Ruby. This is some code that is a real example of where ownership semantics matter in the Rails framework. So active record is our ORM, and most of the specifics here of like all of the code aren't important other than the general idea that user has a setter and getter for a field called name. It's going to coerce that to a string. And what we're doing here is we are assigning a variable called name to a value, passing that into the constructor for this object. And the assumption that active record is going to make here is that it takes ownership of anything that you assign to one of its attributes. It has certain things that it does internally to maintain state with regards to the database, and it needs to be able to know when things are mutated. It needs to know that you're not going to change something out from under it. So if you were to then hold a strong reference to that value and try to mutate it, that would cause bugs. And this was possible in older versions of Rails, and it did cause bugs, and this now actually breaks in newer versions of Rails. But this is the same code, but slightly different. You'll notice here we are no longer mutating the local variable. We're doing user.name and mutating. And so you can actually just eliminate the local variable at that point, and it's doing this. And this is now fine, because when you're calling that name method, ActiveRecord is loaning the name back to you. But the point being, it has this explicit ownership contract that the language doesn't express. But what will occur if you are holding references to something outside or trying to assume what is or isn't shared versus going through the API that it wants you to go through? You get very different results. And so I want to look at a real bug that occurred in Rails. That wasn't just like user code bugs, but an actual bug. This is a person that people who do Ruby will recognize who introduced this bug, and I don't normally like to blame people, but I poke fun at him. So we had this method in some code or this is essentially what the code did. So it accesses the instance variable called env, which is a hash here, and it's trying to say if there is no value at this key, assign it to an empty hash and return whatever the value is afterwards. So the change that was introduced was this. Rather than accessing the instance variable directly, it's calling this getHeader method, and instead of doing or equals, it's just doing or. So get the value at that header or return an empty hash. And the commit message was use getSet header to avoid depending on the env ivar. So the thought process here was just very, very specific. It doesn't give a ton of context about the code, but you can tell exactly what they were trying to do and what they were and weren't thinking about. So somewhere else in unrelated code, we had something that looked like this. So controller.request.pathParameters, that path parameters bit at the end, that's the method that we were just looking at. And it's doing square bracket equals and then trying to assign the result, right? So that is getting the value at that header or returning an empty hash. And in this case, it's mutating it. So looking at this case before, we're always returning a hash that has the same owner. It is always owned by that request object or by that @env ivar. Whereas afterwards, this empty hash, it disappears into the nether. It's not kept anywhere. Mutating it effectively is a no-op. And so if you were to look at the signature of this function in Rust, this is what it would look like. Path parameters takes a reference to self and returns a reference to a hash map. And one thing that's implicit here is that the reference is owned by self. Because it is a reference, and you can't pull a reference out of nowhere. It has to be referencing something that is owned somewhere else unless you want to leak memory. So when you think about this, and you're thinking about ownership, not explicitly, but just in the back of your mind, one of the things that came to my mind when I was trying to figure out what was going on with this bug and I saw this code was, who owns the empty hash? And a lot of this is just about making API contracts very explicit. So you have to think about when you're returning values, especially values that exist in mutable languages, you have to wonder, what do we expect the caller to do with the result of this method? Are they allowed to mutate it? Are they allowed to keep a strong reference to it, or should they be calling the same method every time they want to access it? Are we allowed to mutate it without telling them? Are we allowed to just replace this with a completely different hash? Or is it expected to always be associated with what was first given to us? And so looking at this, looking at the code that introduced this bug, I tried to figure out what was the intention of this change. And this was the commit message. Call the path parameters equals setter rather than rely on mutations. So ultimately, a lot of this code is trying to get away from allowing the result of this from being mutable in the first place. So the signature that we have is we want to take a mutable reference to self and return a mutable reference to this hash map. What we actually want is an immutable reference. So how can we make this ownership contract more explicit in a language that does not give us a way to reason about ownership? So this is a completely different place that had a very, very similar, not actual bug that occurred, but a similar solution. So we used to have this method changed attributes, which would just memoize an empty hash and would get mutated elsewhere. And eventually I introduced code that did this, which if you're not familiar with Ruby, these methods don't matter. The important thing is this always returns a new hash. It is not returning a hash that is stored somewhere, so if you mutate this, it would have no effect. So the return value isn't owned by active record. Your mutations wouldn't be seen by active record. They could be seen by you if you stored it somewhere, but we don't own it. We don't know what you're doing with it. So this was the solution. Freeze in Ruby, for those who aren't familiar, just says make this thing immutable. Blow up if anybody ever tries to mutate this thing. And just like that, the contract suddenly becomes explicit. Nobody can think that the ownership contract with the return value of that function is something other than what it is. So the bug was eventually resolved. This was the change. We're actually still just doing the same thing. That hash does need to get mutated in places, so now we're just making sure that we memoize that empty hash. This was the commit message. Remember the parameter hash we return. Callers expect to be able to manipulate it. But to put that another way, I would describe that as our callers expect to borrow a value that we own. So if this whole process, if this whole commit this whole bug resolution had been gone through with ownership in mind the entire time, I don't think this bug would have been introduced in the first place. I think it's important to think about all aspects of API contracts, and ownership is just one more that we should have in the back of our head. So let's start thinking about ownership in our code, and let's have fewer bugs. I have stickers. They look like this. They're for an ORM that I've recently written in Rust called Diesel. It's the fastest way to interact with databases in any language. You can check us out on the internet at this URL. Thank you very much. I will now take questions.
I just wanted to thank you, and one question about Pony language. Have you heard about it? It also introduces ownership classifiers.
I have not heard of that language, no. But we should talk afterwards. I would love to hear more about it. I will not leave this stage until somebody else asks a question, just for the record. Also, water has bubbles in it here, and that weirds me out. It's not like that in America.
Okay, this may sounds quite ignorant and superficial. I'm going to ask it anyway. So I'm just wondering about, so you started with talking about types and then a notion of ownership.
Right.
What I'm wondering is, because I can maybe because the ownership concept is kind of new to me. But I'm thinking how we can talk about the ownership. Is it an objective entity? Does it really exist, or is it just a sort of reference framework that helps us to think about the protocols and contracts? Because a type system is something very real to me. The thing needs to have a type.
Well, so a type system is very real, right? But the idea of a type is very much not, and you can have very different interpretations of what a type system actually means. And if you look at, say, the Java type system and compare that to, say, the Haskell type system, what it means for something to be of a given type, or actually Go is another good example of a language that has that is statically typed but completely changes what a type means. So I think it's like what I'm trying to. So Rust, part of what I was describing was Rust's specific ownership system. But that is independent of the idea of ownership, and so and so I think it's a very similar relationship where there is the abstract idea of ownership, which is more of that, as you put it, the framework to help reason about those contracts. But then if languages have an actual semantics towards ownership, right? That there aren't necessarily going to be concrete rules for exactly what ownership means in the abstract, but languages may or may not introduce more specifics. Does that make sense?
Hello. Thinking about ownership as like some sort of a horizontal property of the types, would you consider any other properties like that?
Yeah. Thread safety, for sure. Like whether or not something is able to be safely sent to another thread, and whether or not something is able to be safely shared across threads, even if it's immutable. For example, database connection in almost every language is implemented in a way that you cannot share that between threads reasonably. It's an interesting question. There are probably other concepts that would have those sort of same properties. Those are the ones that come to mind off the top of my head, though. We got one down in front. Oh, over there. Okay,
Yeah,
sorry.
so isn't ownership something you have to think about only if you deal with mutable states? Because I can't think of situation in which you would have immutable data and you would have to deal with ownership.
Right, so I knew I was going to get that when I saw the Haskell stickers. So no, but immutable languages do tend to push you towards things that help you express the ownership contract more correctly in the first place. So your data structure is immutable, but you're still going to be making changes to that structure, and those changes need to be reflected to everybody else who needs to care. Haskell, for example, just tends to push you towards the state monad and structuring your functions in such a way that having correct ownership semantics there falls out of that naturally. But there is still sort of the top level, like, I'm responsible for this, and anything else that is going to potentially update this, I need to make sure that I manage those and assign things correctly. Or assign's not the right word, but I think in do notation, so I think of it as assignment. But same in Clojure, right? Like all of your data structures are persistent, but you do still need to represent where those changes are somewhere, and there is a place that is responsible for managing that. Yeah.
Hello, me again. Question was about the first example where you were showing borrowing. Before you were borrowing something.
1 sec.
There we are.
Oh, too far.
Yeah, this one here. So. In the second line where it says, let file blah blah blah, do something. So you own that file at that point.
Right.
Is ownership stopping me call that method at all, or is it being able to make any changes to that method? Because the second slide, I understand does borrowing let me call the method, or does borrowing let me kind of change the file?
So borrowing simply means whether or not you're going to destroy something when you're done with it. So it's in Rust, it's specifically based around lexical scope. So when do stuff with file returns, file is destroyed. And this is a compile time guarantee. It's also a runtime guarantee, but this is a compile time check. But so borrowing just means that by passing it in here, you're not destroying it. Methods in Rust are kind of a thing. They just happen to take self as the first argument, but it's the same thing. You can take a reference to self, or you can take ownership of self. But all it means is that after the second line in main, you cannot, if you do anything with the variable file other than rebinding it to a new thing, if you try to do anything with that, it will fail to compile, because at that point, file is known to be destroyed, so there is nothing that you can do with it. Okay, so in the second example, when I'm borrowing it, I could do something silly like reverse the contents of the file, but I can't destroy it. And you never explicitly destroy things in Rust. They get automatically destroyed just when an owned value exits scope. So you would never. Another way to put it, though, right? You could never call a method that takes ownership of that file, which would effectively be destroying it.
Cool, thank you.
Yeah.
I have a question about ownership and shared pointers. So I worked in 2 big companies in large C++ code bases, and obviously in C++ you got a concept of smart pointers, right? You got unique pointers, which guarantee that something is unique, and that's a strong guarantee that you hold ownership of that. And then you have a shared pointer.
Right.
So in one company, if you introduced a shared pointer, you'd get a punch in the face during a code review, right? It's great. And the other company, everyone just assumed that because ownership is difficult, let's just use shared pointers because it solves the problem.
Right.
How would you recommend to, I suppose, evangelize the other community that shared pointers are not great? Because they seem to work.
Right, well they do, right? And we have shared pointers in Rust as well. So we have RC and ARC, which stand for reference counted and atomically reference counted. But they only allow you to get an immutable reference to the interior contents. References in Rust actually map directly. A mutable reference is basically a unique pointer, and a shared reference is a shared pointer. But basically, like, I guess the way to evangelize it, being the actual question, right? Shared mutable state is sort of the thing that everybody is trying to solve. Shared point. C++ gives you sharing, but doesn't give you ways to manage that sharing well once you have it, or ways to manage the mutability well. So shared pointers kind of give you this gateway to having shared mutable state, which tends to be the source of a lot of bugs, especially if you're in a multi-threaded context.
Hi, here. So there's a trend that goes on, right? Like that over decades, that concepts that people thought about some time ago start to make their way out into the larger world. Mm-hmm. Like what started happening with functional programming approaches, you know, and starting to bring those into other languages where they weren't at first used. And somebody put SICP up on the screen yesterday, and it was kind of like, okay, well. But I wonder, many of the languages that are around are kind of suitable for bringing in functional concepts, but it's interesting that you're showing languages where ownership is not at all explicit, and I wonder do you tend more to think that we want to go in the direction of finding ways to make ownership explicit in those languages, or just using these languages that are doing a better job of making it a concept in the first place? No,
I'm definitely trying to find ways, in the same way that we find ways to reason about types in dynamically typed languages. That is definitely what I'm pushing towards. Just understanding the concepts I found is very helpful. So this slide here, like, I actually would get for quite some time bug reports about like the issues that would occur from this. And basically, once I actually started to understand ownership semantics and reason about them, like, that actually became a very succinct way for me to describe exactly why, no, you're not allowed to do this. Here's the explicit contract that we hold. So that's the first step of it, and then the second step for me was realizing, okay, now let's see if there's ways that I can express this at runtime, which in many cases just turns out to be freezing things, but freezing things or memoizing things tends to be a solution a lot of time. But finding ways to make it explicit at runtime is definitely the second part of it, which isn't always possible.